Okay, so this video is going to be about 9-2, which is going to be about chords and arcs inside our circles. And again, don't forget you're going to have a quiz after section 4. Okay, so in a circle, congruent chords have congruent arcs. So what that means when you're looking at that picture below, it says since EB is congruent to DC, so since the two line segments are congruent, that means that the two arcs BE and CD are also going to be congruent. Okay, the next thing that we're going to talk about today is in a circle, chords equidistant from the center are congruent. Okay, so again, in the picture below, if those red line segments, EF is congruent to EG, then that means that AB is going to be congruent to CD. Again, those are line segment symbols above there. Again, this is an arc symbol, line segment symbol. So just be careful of your symbols because that's going to be important. Okay, the next part of what we're going to do today is about parallel chords. Okay, and parallel chords intercept congruent arcs. So again, what that says is that if AB is parallel to CD, then that means that arc BC is going to be congruent to arc AD. And if you inscribe a quadrilateral inside of a circle, what's going to happen here is the opposite angles of a quadrilateral inscribed in a circle are going to be supplementary. Okay, this is completely different than everything that we talked about in our regular quadrilaterals chapter. Okay, so what does that mean? Again, if I start with A, the angle directly opposite that is angle C. So angle A plus angle C is going to be 180. And if I go to the opposite angles, angle B, and the angle directly opposite that is going to be angle D. So angle B plus angle D is going to equal 180. Okay, and the last part of what we're going to do today is in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and it bisects its arc. Okay, so again, in my circle O here, CD is the diameter and AB is the chord. So if CD is perpendicular to AB, what that means is that AF is going to be congruent to FB and arc AD is going to be congruent to arc DB. So those 5 things that we just talked about on that first slide are going to be how we're going to answer all of our questions today. Okay, so for example number 1, we want to find the value of X. So right now in the picture, they're telling me that arc JK is congruent to LM. Well, if the two arcs are equal, that also means that the two line segments have to be equal. So all we're going to do to solve for X here is take 18X minus 2 and set it equal to 52. The opposite of subtracting 2 is adding 2. And when I do that, I'll have 18x is going to equal 54. And then we'll divide both sides by 18. And x is going to equal 3. For number 2, we want to find the measure of arc RS. Again, this is directly the opposite of what we just talked about in number 1. This time you're told that the line segments are congruent. And again, if those line segments are congruent, that's going to mean that the arcs are congruent. So again, to solve for x, the first thing that we're going to do is set those two things equal to each other. Okay, and again, when you solve here, it does not matter which one you get rid of first. I'll subtract 5x from both sides. So I'll have 6 equals 6x minus 72. I'll add 72 to both sides, and I'll have 78 is going to equal 6x. Divide both sides by 6, and x is going to equal 13. Just be careful here. It's not asking you to find the value of x. It's asking you to find the measure of arc RS. So now I need to plug back in. So the measure of arc, that's an arc symbol there, arc RS was represented by 11x minus 72. We just found x to be 13. So I'm going to do 11 times 13 minus 72. 11 times 13 should give me an answer of 143. And if I take 143 and subtract out 72, that should leave me with an answer of 71. So the measure of arc RS is going to equal 71. For number 3, we want to find the value of x and y in the diagram. So again, I have a quadrilateral inscribed inside of our circle. And again, what that means is that the opposite angles are supplementary. So it doesn't matter which one I solve for. First here, I'm going to solve for x. So the angle directly opposite x is the one that's labeled 112. So to solve for x, that means that x plus 112 is going to equal 180. And all I have to do is subtract 112 from both sides. And that means that x is going to give me, is going to give me an answer of 68. Okay, and then we'll do the same thing for y. For y, the angle that's directly opposite that is 81. So this time we'll do y plus 81 equals 180. And when we subtract 81 from both sides, y is going to give me an answer of 99. Okay, so a quadrilateral inscribed inside of a circle, opposite angles are supplementary. Again, it is completely different than what we've talked about in our quadrilaterals chapter. Okay, second one for this slide, in quadrilateral OPQR is inscribed in circle N, and again, we want to find the value of x and y. So again, opposite angles are supplementary. Again, it doesn't matter if I solve for x or y first. I just put an arrow to my two opposite angles that have the x in it, so let's solve for x first. So again, those two are going to be supplementary, meaning they add up to 180. So I'm going to do 2x plus 2x plus 4 equals 180. Or 4x plus 4 equals 180. Subtract 4 from both sides, and 4x is going to equal 176. Divide both sides by 4, and x is going to equal 44. For my y's, again, the y and the 3y plus 8 are directly opposite each other, and again, that means that those two angles are going to be supplementary. So y plus 3y plus 8 equals 180. Or 4y plus 8 equals 180. We'll subtract 8 from both sides, and 4y is going to equal 172. The opposite of multiplying by 4 is to divide by 4, and y is going to equal 43. For number 5, if DE equals 11x plus 15, DE is this segment here, and FG equals 32x minus 27, we want to find eventually the length of DE. So again, you can see you have these little hash marks here. Again, so those two line segments are equidistant from the center of the circle, which means that the two line segments, DE and FG, are going to be congruent. So to solve for x here, we're going to again set those two things equal to each other. So 11x plus 15 is going to equal 32x minus 27. Again, doesn't matter what I do first here. I'll get rid of my 11x by subtracting 11x from both sides. So I'm going to have 15 equals 21x minus 27. The opposite of subtracting 27 is to add 27. So 15 plus 27 should give me an answer of 42. So 42 is going to equal 21x. The opposite of multiplying by 21 is to divide by 21, and 42 divided by 21 is 2. So your value of x is going to be 2, but again, just be careful. The question's asking you to find the length of DE. It's not asking you to find x. So DE, again, was represented by 11x plus 15. We just found out that x was 2, so we're going to do 11 times 2 plus 15. Or we'll do 22 plus 15, which is going to be 37. So your length of DE is going to be 37 altogether. In circle O, DC is the diameter, DC is perpendicular to AB, and AB is 14, and OE is 24, and we want to find OB. Okay, so OE is this piece here that I'm just highlighting in red. That's going to be 24. Okay, and again, we're told that this is a right angle because again, that was perpendicular from up here. And the entire length of AB is 14. So if I have a diameter and a chord that's perpendicular, again, that means that that chord is going to get bisected. So AB is being bisected by CD. So if the entire length of AB is 14, that means this piece is going to be 7 and that piece is going to be 7. Okay, and I want to find OB, which is this segment here. Okay, well, very simply, I just completed a right triangle in red, and I want to find the missing side of a right triangle. So again, the formula to find the missing side of a right triangle is going to be your Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. Okay, and again, the only thing that matters is what you plug in for c. C has to be the side directly opposite your right angle. Directly opposite your right angle is x. That means x has to go in for C. It does not matter how you plug in the 24 and the 7. So I'll do 7 squared plus 24 squared equals x squared. 7 squared is 49. 24 squared is going to be 576. And that's going to equal x squared. Add the 49 and the 576 together. That's going to give me an answer of 625. So 625 is going to equal x squared. Again, the opposite of squaring something is to take the square root. So we're going to take the square root of both sides. And it just so happens that 625 is a perfect square. When you take the square root of it, you should get an answer of 25. So 25 is going to be your answer there. I don't need to plug anything in. It was asking me to find the length of OB. That is OB. I'm done. Next question is going to be based on that same picture, but this time they're telling me that OB is 15 and OE is 12. Okay, and eventually I want to find the entire length of AB. But to find the entire length of AB, the first thing I'm going to do is I'm going to find EB. And again, because this is a diameter and a chord, they bisect each other. So once I find EB, that's going to be the same length as this AE. And then I'll just add the two pieces together in the end. I still have a right triangle. So again, we're going to use our Pythagorean theorem here. So a squared plus b squared equals c squared. And again, this time though, the side opposite your right angle is 15. So 15 has to go in for C. So I'll do x squared plus 12 squared equals 15 squared. 12 squared is 144, and 15 squared is going to be 225. I'll subtract 144 from both sides, and x squared is going to equal 81 when you subtract. And again, the opposite of squaring something is taking the square root. And when I do that, that means that x is going to be 9. So again, what we found is the length of EB. So EB is 9, which also means that AE is 9. So AB is going to be 9 plus 9, or if you want to say 9 times 2, either way, 9 times 2 will give you an answer of 18. And our last one, use the circle pictured to find each. The first thing that we want to find is VW. Hey, there's no arc above that or anything like that. Remember, if there is no arc, there is nothing above it, that means it's a line segment. So you want to find VW here. So we want to find this entire purple line segment. Okay, so again, to do that, let's see what we have. Okay, I'm going to look at this red right triangle again. Again, we're going to do the same exact thing we did on the last slide. Okay, again, if I extended this, this would be a diameter. Okay, it's a radius right now, but now it's a diameter. So if you have a diameter and a chord, if I find WZ, that's going to be the same thing as ZV, and we'll just add them together. So once again, we're going to do a squared plus b squared equals c squared. And again, just keep in mind that the side opposite your right angle has to go in for C. and I'll call the piece that I want to find x. So we'll do x squared plus 5 squared equals 13 squared. 5 squared is 25. 13 squared is going to be 169. Ooh, sorry. Okay, we'll subtract 25 from both sides. And x squared is going to be 144. The opposite of squaring something is taking the square root, and x is going to be 12. So again, if this side is 12, that means that this piece is also 12. So altogether, the entire length of VW is going to be 2 times 12, or again, 12 plus 12 is 24. Okay, and then the last thing that we need to find is the measure of arc YW. So YW is right here. So again, that is going to be, try to clean up my picture a little bit. That is going to be directly opposite this central angle right here. So if I can find that central angle, then the measure of that angle is going to equal the measure of that arc. Okay, so now we're going to have to go into our bag of tricks. So how am I going to find the measure of angle X? Hey, again, if I look at the triangle that I had highlighted originally, I know it's a right triangle, but I'm missing 2 angles. So I can't do anything with the 3 angles of the triangle adding up to 180. However, I can find the measure of the angle using trig. So the first thing that we're going to do here, first, we're going to find the measure of angle X. Okay, and how am I going to do that? I'm going to use trig. What's trig? SOHCAHTOA. Okay, so again, I'm concentrating on this triangle. I'll concentrate on this is 12 again. Hey, it doesn't matter which trig function you use here because you have all 3 sides of the triangle. I'm going to use the tangent of x. So I'm going to use the opposite and the adjacent. So the side directly opposite this angle, angle x, is going to be 12, and directly adjacent is going to be 5. So the tangent of angle x, the side opposite is 12, the side adjacent is 5. Remember, you're looking for the measure of the angle, so that means inside the calculator, you are doing tan inverse of 12 divided by 5 and hit enter. Again, just make sure you're in degree mode, all that stuff from chapter 7. I know it's going back a little ways now. And that means the measure of angle X is going to be 67 degrees. If angle X is 67 degrees, again, that's a central angle, and its intercepted arc are equal, which now also means the measure of arc YW is also going to be 67 degrees. Again, the measure of the central angle and its intercepted arc was from the last section, and again, they are congruent.